Cool. 120 triangle. Given a triangle, find the minimum path sum from top to bottom. Each step you may move to adjacent numbers on the row below. For example, given the following triangle, some number, the minimum path sum from top to bottom is 11. Bonus point to be able to do this using O of n extra space, where n is the total number of rows in the triangle. Okay. I mean, it depends how you want to define space. You can actually just use the input anyway and mutate it. But I assume that's not as cheerfully looked upon. But um, but yeah, I mean, I think this is actually standard E, and this actually so I think yeah, so this goes back to what we were talking about earlier with bottoms up and top down. So you could certainly do this one from top down with recursion and stuff like that, but then you're not going to be able to do it in O of n extra space. So you have to do it in dynamic programming in this particular case, or sorry, bottoms up dynamic programming to get the O of n extra space requirement, and I think that's what we're going to do. Yeah, I mean, I think this is to be honest, a standard E problem, but yeah, where X looks for, yeah, okay. And I'm actually just going to be, yeah, the thing to note is that for each row, you only need to look at the row -1 or the row on top or the bottom, depending on how you want to show it. I think it's symmetric. Um, it's just that if you don't do it symmetric, I mean, it's symmetric, but if you depending on how you want to do it, some ways are a little easier than others. But yeah, okay. So how do I code it? Yeah, let's start from the end. Just I, right? Maybe I plus. No, it's I. Okay. So I think this one actually I could have gone from 0 to maybe 2. Yeah. Okay. So I know I said I was going to do things in place, and you could certainly do it, but I think just for the sake of my practice, actually, I'm going to do this in, what you got. Where's max? I guess they don't tell you. That's a little wrong. Maybe I should have done this in Python. Couple of ways to do this, but let's do it this way. N or n plus 1. Yeah, sure. And I think it's fine. I think just enter. Okay. So let's say. So we want to set up. So the first row is the base case. So we just have to do this where before so I is equal to triangle I and minus 1 I. Okay, that's the last row, setting it up. So now we actually could begin here. So, well, first of all, current sub j is equal to triangle of ij plus before sub j, or so take the minimum from the one that's under or the one under and to the right. Okay. I'll just do a min for you. Okay. I think that's it. So that's each of my frames. So now temp is equal to, I guess I should leave it. Do I need temp? Yeah, I do. Okay. Because we want to swap the rows. So there another way to do this, I think, where you just use a two-dimensional or like a matrix with two elements, and then you kind of swap them. But I think this way is slightly clearer. But oh, sorry. Before is equal to current, temp is equal to before, current is equal to temp. So basically, and this is a maybe C specific, but it's this may actually be wrong. No, before. Yeah, I'll just do it something later. But yeah, but this just swap the pointers so you could kind of reuse the same arrays. I mean, you could do that in Python too, right? It's just different, swapping references. So it's not C specific, I guess, actually. But okay. So you want to return current sub 0, kind of, but is it current? Because I think that doesn't remove 0 rows. Maybe I could just select this. Okay. It's roughly right, maybe, unless I get like a sick row or something. Or something even worse. But oh, I might not have added one thing. It's even a better path. But I think I just didn't add the 2 at the end for whatever reason. So I think that's the answer for, because we swapped the current, so then current is actually the last row's best answer. So if I do before, actually, it should work. But okay. Let's do normal way. One element. Well, that's why we test it. Maybe I just special case it. Okay. Why did I print? Oh, maybe their stuff crash on empty array. Okay, then maybe I don't need this as an input then. Okay, should be okay. If I miss an edge case, I'll just fix it. I'm a little lazy. I gotta think about everything. Okay, cool. Yeah, Yeah, so this is kind of the actually very related to what we were just talking about, or obviously a easier example to understand, because you could actually think about, because if you would do it kind of top down, then you would definitely need an n square matrix to represent all these, each of these. Um, and even with bottoms up, you could have easily done it with a two-dimensional matrix, but this allows us to kind of because we know that you only care about the row on top or on the bottom the way I did actually, but either on top or on bottom, then like yeah, you only you only need to know the content for last row, so you don't have to over allocate memory for stuff like that. Cool. Um, so that's kind of the explanation for this problem. This is a relatively straightforward E problem. I mean, I think this also is one of those canonical dynamic programming problems. So that's why I'm able to get it very quickly, and hopefully, I guess that feels good. I think one cool thing I want to point out is that I actually implement not this per se, but a similar thing. How long ago is it? Like maybe I want to say 10 to 15 years ago. It actually comes up in a real world thing. Well, for some definition of real world, anyway, if you're interested about these stuff, is if you ever play around with like Adobe Photoshop or something like that, where you take an image and then you kind of resize it, either squeezing, let's say squeezing them together, right? And squeezing them together, there's obviously you just do a rescale is one way you could do the uh, the resizing. You just kind of squish things together. Another cool thing that they call is was it content aware or it's either content aware or content sensitive, but I forget what naming they call it these days. But let's say content aware resizing, and what happens there is that, and once you're kind of familiar with this problem, is that it actually takes a minimum cost path from the top and the bottom or to the bottom, and then delete that path. So and the cost function, you can play around with it, and I think they tweak it around over the time. But a really naive cost function is just like, well, look at the surrounding colors. Like you want to basically a cost function that is as similar to the cost of the nearby cells as possible. And to translate that into English, it means like let's say you have nothing but blue skies, then yeah, then your assumption is that no one would miss it that much if you miss like a sliver of blue sky, right? Like versus if you take away, I don't know, say half my face or something, or like 2 3 columns off my face, then like you'll notice that I don't have a nose or something, right? I don't know. So that's kind of the idea behind that, and that is, as you can imagine, finding a minimum cost path from the top to bottom using this cost function. Uh, that is using dynamic programming, and that's actually one of the cool like earlier things that I learned about back in the day. I'm like, oh yeah, wow, you actually do use dynamic programming these things, and I definitely worked like played around with some projects on that, and it's kind of cool. I guess nowadays everyone takes all these magical things for granted, but like with image manipulation and stuff like that. Cool. But yeah, I think this is a very standard problem, so I very much would have expected. This is yeah expected on an interview, I would say probably. Uh, and I don't really have much of a postmortem. I think I keep saying postmortem, but I mean retro. Just because I feel like this is relatively straightforward. Let me know if y'all don't